So let's do this one. It's talking about Blake and Carlos and Angela's watching from the side. The very first thing they ask you to do in part A is to do a motion map of Blake from Angela's point of view. And if you remember, those motion maps are those dots, kind of like we did with the buggy in the beginning. So let's do it from Angela's point of view. And I'm just gonna pick a random amount here and try, and it's not critical that I'm super accurate here. But the point is this. I'm gonna pick some distance here, kind of spread out, and imagine that that is where Blake appears to be to Angela every single second. So when I go to do it from Carlos's point of view, Angela's standing on the side. She's gonna see Blake moving with this distance here is gonna represent the combined velocity of Blake running and the train. But Carlos, in his frame of reference, he's only gonna see Blake moving, not this train speed, but just him running. So it's going to be a much smaller distance each time. So I would just draw my dots much closer together. So again, you can imagine a slower buggy moving along. If you marked where it was every second, the dots would be a lot closer there. So exactly how fast does Angela see Blake going? Well, this is a pretty easy problem to do. Let's just call to the east positive, and in fact, I think they say to label the direction positive on here, do they? Anyway, this is the positive direction. So positive 2 meters per second east of Blake running and positive 5 meters per second east of the train moving. So we add those two together. So Angela will see Blake moving at positive 7 meters per second, or you can call that 7 meters per second to the east is how fast she'll see him moving. So then in the next part, let me pull that diagram up here. So now he is running, this is at the bottom of the front side of the worksheet here. He's running 2 meters per second to the west. Well, let's just consider that negative 2 meters per second. The train's still going 5 meters per second east, consider that positive. So just add the two together. 5 plus negative 2 is positive 3 meters per second. Or again, you can just write the direction as east there. So then you flip it to the back side, and we've got case A here and case B. In case A, the train's going 10 meters per second to the east, and Blake is running 20 meters per second to the west. So I'm gonna add a little negative there and a little positive there. And then in case B, Blake is running 10 meters per second to the east, and the train's still going 10 meters per second to the east. So what you're supposed to do is to circle each person's correct statement. So Blake says this: I'm running the fastest in case A. Therefore, I will appear to be moving fastest relative to the ground. Who cares what the train is doing? So from his point of view, you can say that this is correct. Relative to the surface he's on, he is running the fastest in case A. He's running twice as fast here, as far as he's concerned, as he is there. But the rest of what he's saying isn't true. So then Carlos says here, no, the train does matter, but since 20 plus 10 is greater than 10 plus 10, you are right that in case A is where Blake is the fastest. So Carlos is getting the right idea here that the train does matter. So we'll circle that for him. And then Angela here says, Blake is running the fastest relative to the ground in case B because Blake's velocity and the train's velocity are the same direction and add up to 20 meters per second. So plus 10 is plus 20 meters per second. But in case A, Blake's velocity is in the opposite direction of the train. So negative 20, positive 10, they add up to 10 west. So negative 20, positive 10, negative 10 meters per second. So pretty much everything Angela said was true here.